So to get started, Shawn, can you tell me like where you grew up, where you went to school, what you did for your undergraduate and graduate degrees, and that sort of thing?
Sure. So, um, again, my full name is Shawn Hitchcock. I grew up in Detroit, Michigan, where I went to Wayne State University for my undergraduate degree. There, my degree was focused on chemistry. I was considering chemistry education, but when I had a chance to do undergraduate research in organic chemistry, that was the thing that really uh, caught my passion. And so from there, I went out to the University of California, Davis to obtain a PhD in synthetic organic chemistry. And then after that, I went to the University of Wisconsin-Madison for 2 years for a postdoctoral study. And I concluded that in 1998, and then I landed a position at Illinois State University's Department of Chemistry.
So can you tell me some of the things that are really important for your students and for you that are generally taught in introductory chemistry courses?
Absolutely. So for organic chemistry, we're focused on a lot of what's called synthetic methodology, where we're trying to develop methods for making materials. These materials can be life-saving drugs. They can be polymers that we use in our homes every day. And so for my research group and for my students, we use general chemistry concepts each and every day. So for all of the chemical reactions that we are conducting, we're always using stoichiometry. It's essential that my students are able to rapidly make determinations about limiting reactants or excess reagents. Beyond that, I need my students also to be able to create standardized solutions. So for instance, for some of our chemistry, we need solutions of hydrochloric acid that have fixed molarities. And so we're doing calculations all the time. And so for the students who are in my research group, I count on them having strong background in general chemistry so that not only can they understand the conceptual aspects of organic chemistry, but also the aspects surrounding the all of the calculations that we do.
What sorts of things as general pieces of advice for studying introductory chemistry would you have for people, or for getting how to make progress as a new student at a university?
That progress is something that sometimes it's difficult for some students coming out of the high school experience where they may not have had to study as much to be successful. Well, certainly things do turn around in the collegiate environment where there's a greater demand for understanding. And the best way to accomplish that is by immersion. There's no way to get around it. The best methodology that I've seen applied by students is that methodology where they are spending quality time making sure that they are truly understanding a concept, doing all of the homework that's been provided, and then even going beyond the homework that's being provided. The only way that you really master this material is through a constant exposure and dedicating yourself to making sure you understand the material. It's not enough to go through the motions and to say that you've gone through 3 examples and you understand the concept. That's not really enough. My recommendation is to if look at the problems from the standpoint of, well, if 3 problems have been assigned, maybe you might want to do 5 or 6, or look at the problem and try to rewrite it from a different perspective. Because often for many general chemistry problems, they tie back into mathematical problems. And we know that for math, there's many ways that you can come at a problem and come up with the same solution. For chemistry, often it's the same way. And so that it requires this creativity that you do not get out of just working on a series of simple problems. I encourage students to challenge themselves. If they've run through a series of problems, can they rewrite that problem? Can they look at it from another direction so that they can understand the concept as a whole rather than just a formulaic problem? That's my recommendation.
It sounds like you were describing me, Shawn, because I know that coming out of high school, I'd never really had to do any work. And so I arrived as an undergraduate with virtually ability to study. I didn't really know how to study, didn't really know that I needed to. And I would look at problems and look at what was assigned and say, oh yeah, I understand the concept, I can do that. And then I'd find that when I was on an exam or something like that, I would just it'd be like the first or the second time I'd ever really worked my way through a problem. And it was just never enough time. And so I nearly crashed out my first and second year. And so, yeah, it sounds like you're describing me. So.
Oh yeah. Well, I think that methodology worked for me. Coming out of high school, I had a similar experience. Was where I was the highest performing student in my class in high school, but on my first exam in college, I was a little blown back. I was not the highest scoring person on that first exam. Matter of fact, I was below average. But that's when I realized that I had to immerse myself, because at that time I was thinking that I was going to become a chemistry teacher, and I realized that often people need to hear different explanations of how to get to an answer to really understand the problem. And so I trained myself to look at all of these problems and come at them from different directions. I was taking pre-calculus at the same time I was taking that general chemistry course, and I learned a lot from that math class. We spent so much time attacking problems from different directions. I realized that for chemistry, it's the same thing. Okay.
One of the things that I'm trying to do this year is really encourage and promote ways in which students will work with other students, and that can certainly lead to seeing other people's approaches and other people's perspectives. And that may help some students to find those alternative ways and to develop that more broad and deep understanding.
Oh, absolutely. Well, one of the fun games that I had developed with my brother was taking chemistry the year after I took chemistry. And one of the games that we had in terms of trying to look at things from different perspectives was calculating tips at restaurants. It turns out that it seems like it's innocuous, it has nothing to do with chemistry, but you'd be surprised. Different people will calculate the tip in different ways, but all of those different ways contain the same themes that allow them to come to the correct answer. Right. And so, yeah, this ideal of trying to train yourself to attack problems from different directions, it really pays off.
And I think it pays off if you're a chemistry major, it pays off if you're a biology major, whatever your chosen path, it'll pay off.
Yeah, absolutely.
Yeah.
Because looking at problems from the standpoint of that linear thought pathway of here's the formula for solving it, apply the formula. If students limit themselves to that, they'll never be able to get to that point where they truly understand how to attack a problem. So it's stepping away from that built-in algorithm of, okay, this is how we solve the problem, and then developing new thought pathways that lead into answers.
Well, thank you, Dr. Hitchcock. I appreciate you taking the time today and bearing with me through our previous technical problems and that sort of thing. So, yeah, enjoy your time in the lab today.
All right, thank you very much.
Okay, all right, thank you. All right, bye-bye.
Bye-bye.